everybody. This is our first video for our AP Precalculus series.
Today we're going to be talking about 1.1, which is change in tandem. Alright guys, so these are the learning objectives. Essentially, we'll just be talking about what a function is, increasing and decreasing functions, and concavity.
So a function is basically a graph where each x value has only one y value. So right here is the definition using the terms College Board wants. In AP Pre-Calc, you are not supposed to say x and y. Instead, they want input and output values. So just keep that in mind when reading any definitions or when you're writing answers. So the vertical line test can be used to figure out if a graph is a function or not. So if you just imagine a vertical line and you drag it across the graph, if that vertical line touches the graph more than once at any point, then it's not a function because then that means an input value would have multiple output values.
For example, this circle isn't a function because when the input value is 4, there's two output values, one at 0.3 and one at 8.25, so it just isn't a function.
Next, we have increasing, decreasing tendencies in functions. This is like an official definition for it. Next slide, we'll have a picture, so it'll make more sense. But you can pause to read it. But it basically means that y values or output values, if they become greater over an interval, that means the function is increasing. If they become less over an interval, then that means the function is decreasing. So for example, we have a parabola here, and the input value A is greater than the input value of B. So that's basically telling us that from f of B to f of A, we're going across an interval because we're going left to right. We're increasing our input value. And since f of B, the value with the smallest input value is greater than f of A, since it's 2 versus 0, that means that the function here is decreasing.
Okay guys, next we'll be talking about concavity, which is honestly confusing at first, but the more you get practice with it, it'll become less confusing. Concavity just describes the change in the rate of change of a function. So if something is concave up, that just means the rate of change over an interval is increasing. And if something is concave down, that just means the rate of change over an interval is decreasing. And when a function changes from concave up to concave down, there's a point of inflection.
So here's an example of what we mean by point of inflection and concavity. So right here at this graph right here, the slope or rate of change. Precalculus wants you to use the word rate of change instead of slope, but they mean the same thing. So rate of change here is 2. Then as you go along the interval, 0 and -4. This pink portion right here is concave down because rate of change decreases as you go along the interval. Now, if you look at this red portion, it starts to increase. The rate of change goes from -5 to 0 to 3, so therefore it's concave up. And this point right here is the point of inflection. So that's where it goes from concave down to concave up. And this also applies if it goes from concave up to concave down.
Okay, if concavity is confusing to you, there's a little rhyme that can help. So there's concave up, like a cup. So when the graph is upwards, like it could hold water, that'd be concave up. And then there's concave down, like a frown, which is when the graph looks like a frown. So that's when it'd be concave down.
So this is our first example out of 3 examples. And in each example, we're going to be talking about increasing and decreasing, where the function is increasing and decreasing, and then concavity. So over which intervals is the graph increasing? Now that's when you go across an interval, the output values increase. So we can see that it goes negative infinity. So because there's an arrow, which indicates negative infinity. And then right here is where it stops increasing, which is roughly negative 1.7. So it would be over this interval, negative infinity, negative 1.7. And if we look from this point to this point, that's also where the output values are increasing as you go along the x-axis. So that's roughly negative 0.5 to 0.6. Now, all values in all of our examples are estimated, so we're just going to be eyeballing it. And as far as we know, when we're describing concavity and increasing, decreasing tendencies, when we're using our intervals, there's either parentheses or brackets. Now, we're not quite sure which one is the right answer. We've seen both. In our PowerPoint, we're just going to be using parentheses for consistency, but we were told that it doesn't matter. But of course, check with your teacher. So just keep that in mind. Anyways, so for increasing, those are the points we mentioned. Now we're going to do the same thing with decreasing, except looking at the intervals in which the output values decrease as you go along that interval. So from this point to this point, you can see that the graph is going down, it's decreasing, and that's roughly negative 1.7 to negative 0.5. And then again, we can see here it decreases 0.6 to infinity. So that's what our answer would be. The next question is, over which intervals is the graph concave up? So again, that's when the rate of change increases as you go along an interval. So as the input values increase. Now, something important to note is that in precalculus, point of inflection, so that's where it goes from concave up to down or down to up. For the point of inflection will be indicated with a dot if it's needed for an answer. So right here and here, these are roughly our points of inflection. Again, everything is estimated, so you don't have to worry about finding it yourself. All right, so concave up, like a cup. So right here, between these 2 points of inflection, is where it would be concave up. So that is roughly negative 1.25 to 0.1. And then for concave down, so where rate of change decreases, that would be these sections because it's down like a frown. So we have negative infinity to negative 1.25, this point of inflection, and then this point of inflection, 0.1 to infinity.
Okay, so this is our next example. Over which intervals is the graph increasing? So this is kind of a trick question. It's always increasing because as you increase the input values, the output values are always increasing. So that means the graph is never decreasing. Over which interval is the graph concave up? So as we said earlier, concave up like a cup. So this part is like kind of like a cup, I guess. So that would be concave up from 0 to infinity. And then concave down, right here, it's concave down like a frown from negative infinity to 0.
So we have our last example over here. Which intervals is the graph increasing? So we can see right here from negative infinity to about negative 0.2. That's where the output values increase as input values increase. And we also have this point, which is about 1.6 to infinity. So those are our points where it's increasing. Decreasing would be between these 2 points, so about negative 0.2 to 1.6.
All right, so next we have concavity. So the graph is concave up from approximately 0.7 to infinity. As I said before, it's like a cup. And then the graph is concave down from negative infinity to 0.7. So that is concave down. And that dot right there is the point of inflection. So when it changes from concave down to concave up in this case. All right, guys, so that was 1.1, change in tandem.
Thanks for watching our first video, and we'll have more to come. AP Precalculus and SAT math videos, and we also have example videos, hopefully.
Bye, guys.
Bye, guys!